Hey, good morning. It's Mrs. Pasternak. Today we're going to be starting our statistics unit. You desperately need your graphing calculator, or you're going to use your graphing calculator app. Desmos it can't help you on this at this point. So you need some version of your graphing calculator or a TI-84 app that you can use either on your Chromebook or maybe on your phone or something else. Okay, so it says, how do we find statistical measures from a list of data and from a graph? So I'm basically taking almost like 4 lessons and combining them into one. So I'm going on the premise that you remember a bunch of things from 7th grade statistics. I will review them as I go through my lesson, but I'll be really honest with you. I redid this whole lesson, and it's basically took 4 different lessons that I normally teach in 8th grade, and I put it into one lesson, okay? So let's start with Mr. Aquero's class received the following test scores: 70, 65, 90, 85, 72, 64, 90, and 83. Okay, so the first thing it's asking us is the sample size. So sample size is basically how many items are in the list of data. So basically you can count them up: 1, 2, 3, 4, 5, 6, 7, 8. And there are 8 pieces of data in your sample size. To find the mean. So to find the mean, normally you would add them all up. You would find the sum. And you would divide by the number of items. Okay, that's what you did in 7th grade. I'm going to teach you a cool trick. How to use your calculator in a moment. I'm not going to do these the way that you would have done them in 7th grade, but I'm just going to talk about what you do know. So that's mean. Mean is another word for average. Okay. Median. Median is the middle number. So basically I'd have to reorder my data and put it in order from least to greatest. And I could do that by starting with the smallest number, which in this case is 64. So 64, 65, 70, 72, 83, 85, 90, 90. And double check that you have 8. 1, 2, 3, 4, 5, 6, 7, 8. For median, you'd count into the middle number and so in this case, 1, 2, 3, 4, 1, 2, 3, 4. There's actually 2 middle numbers. So I'd have to take the average of those 2 numbers to find the median. So that's how you did it in 7th grade. Again, I'm not going to do that right now. I'm going to show you how to use your calculator in a moment. Mode is the number that appears most often. In this case, the only number that repeats is 90. Min or minimum, sometimes we call that lower extreme when we're doing a box plot or box and whisker plot. The minimum number here is 64. The max or the maximum number or the upper extreme, is the highest number, which in this case is 90. First quartile is the lower quartile, so basically it's from the lower half of the data. You find the middle number of the lower half of the data. So your median is somewhere there in the middle, and then you'd count into the middle here. There's 2 middle numbers, so I'd have to find the average of 65 and 70 to find my lower quartile. Again, I'm going to show you on your calculator. Here, 83, 85, 90, 90. Count into the middle. It would be somewhere in between 85 and 90. Okay. So range is highest minus lowest. So 90 minus 64. Your calculator won't do that one for you. So you're going to get 26. I think I did that right. Interquartile range is my upper quartile minus my lower quartile. Sometimes they call that Q3 minus Q1 for the third quartile and the first quartile. All right, so let's talk about our calculator for a minute. I'm going to show you how to get the ones I didn't do. So basically mean, median, first quartile, third quartile, and then we'll use that information to do interquartile range. Interquartile range, by the way, and range really talk about the spread of data, how spread out something is, the variability. We used those words last year as well. Okay, so let's talk about how to do this on our calculator. So you're going to go into stat in your calculator, and you go under 1 where it says edit, and you're going to clear out anything that you currently have in your L1s, L2s, and you're only going to be punching in things in your L1. So head to L1 and you're going to plug in this list of data, and you do not have to put it in order. So I'm actually going to write it the way that it says. So 70, everything goes under L1, 65, 90, 85, 72, 64, 90, 83. And you should have 8 pieces of data in there. It'll say L1 with an 8 next to it, and all 8 of them should be in there. Okay? You're then going to hit Stat, you're going to hit Calc, and you're going to pick 1, which says 1 variable stats. So the 1 variable stats, because I only have one list, and I'm going to hit Enter a whole bunch of times. And then it gives me like a ridiculous amount of information. So the X bar is a fancy way of telling me it is the mean. See this X bar? I wrote it there. It's not going to tell you that. You have to learn that X bar, X with the bar over it, means the mean. The mean in this case is 77.375. Your calculator gave that to you as the first value. That kind of makes sense if I added these all up and I divided. 77.5 does seem about reasonable that that's the average of all of those numbers. You're going to skip down a bunch. So 1, 2, 3, you're going to skip the next 4, go to n equals 8. N is my sample spot size. That's how I got this one right here. N is 8. So min is my lower extreme or the minimum, which you all told me was 64. That's here. That was next. So scroll down a little bit now. You're going to see min, Q1, med, Q3, max. Does everybody see what I'm looking at now? So I have n, min, Q1, med, Q3, max. So the min is my minimum, which is 64. Max is my maximum, which is 90, which we got already. Q1 is my first quartile or my lower quartile. So it uses the letters Q and 1. So you have to recognize what that means. That's 67.5, and that is my lower quartile. The med or median, is the middle number, and that is 77.5, which basically makes sense. It's somewhere in between 72 and 83, which I agree. The third quartile, it says 87.5. And max, we said already, was the 90. So to find the IQR, I'm going to move down to J here. I have to take these two values that they gave me, and I have to subtract them. And I get 20. So there's definitely a bunch of things that your calculator is actually going to do for you. Most of the stuff in blue here. So mean, median, actually this one min. So I could circle. So this is on your calculator. Mean, median, min, max. First quartile, third quartile. So 1, 2, 3, 4, 5, 6, 7. These 7 things are given to you on your calculator once you plugged in your data correctly. Mode you should know is the most. You should know range is highest minus lowest. And then IQR, once you are given your Q3 or your upper quartile and your lower quartile, your Q1, you can subtract them and get your range, interquartile range or IQR. Okay, so that's a lot of review from 7th grade. I hope you know that, but the new concept here is that your calculator does a lot for you. Okay, so I went over these words. Mean is the average found by adding up all the numbers and dividing by the number of pieces of data. The median is the middle number set of data that is arranged in numerical order. If there was an even number of data like there was in the do now, you had to find the middle or the average of the 2 middle numbers. Mode is the number that appears most often, and the range is the highest number minus the lowest number. So that's all review. Okay, this should be review, but I don't really know what you remember. So there was 4. So there were 4 different types of distributions that you learned about last year. One is called the normal distribution, which basically looks like a bell curve. So it has a low, a lot in the middle, and then a high. So for a dot plot, and I could probably make this a little bit bigger here, all the dots seem to be mostly in the center. There's some dots low on the left and some dots low on the right. So it says the highest peak is in the middle. There's no real outliers. The mean and the median would be exactly the same. Okay? Oop. Oh, boy. I don't like to change things around here. Okay, if I'm looking at it as a box plot, so that's a dot plot. If I'm looking at it as a box plot, it's called a normal distribution. It's symmetric. Basically, the median, that's this middle line in the center here, really goes in the middle of the box. So it's the center of the dot plot. And then there's basically very similar whiskers on the right and the left. There is no outliers. So no outliers, which basically means I don't have any like long whiskers. So that's what a dot plot looks like this, where it kind of like goes up and then goes down like a bell curve. And the box plot looks like a basic box with a median right pretty much smack in the middle and even whiskers on both sides. That's called normal distribution or symmetric. Skewed right. So skewed right basically means that it has a mean that's greater than the median. And it basically tells you that all the data is mostly on the left of a dot plot and the tail is on the right-hand side. That's how it looks. The tail is on the right-hand side. There's basically some sort of outlier that's very high that's raising the mean to be greater than the median. So a bunch of the data is on the left, and then there's sort of a tail on the right, and we call this skewed right. So in a box plot, it shows you there's a really long whisker here because there's some sort of outlier, and the median gets kind of pushed down towards, this is my median, it gets pushed down towards my first quartile over here. So you see how the line in the center is no longer in the middle? It's more pushed to the left because the median is lower now because of this outlier. So we call this skewed right, which is a little weird because the data is really more pushed to the left, but the tail or the long whisker is on the right. That's why we call it skewed right. Skewed left is basically the opposite. So there's a lot of an outlier that's really low down here. There's some sort of number that lowers the mean. So the mean is going to be less than the median. And then the tail is on the left. Most of the data is on the right. The median gets pushed to the third quartile, as you can see here. And you can see that my tail, or my lower whisker, I should say, I have some sort of outlier that's like kind of, the whisker on the left is much longer than the whisker on the right. Okay, so those are the three. The other one that's not here, which is worth mentioning, is called uniform. Basically, that is, if it's a dot plot, it's basically showing like an equal number of dots. Kind of looks like that. Okay. So meaning it's pretty much the same going around. All right, so let's move on. So I've reviewed all that. Now let's talk about dot plots and reviewing that. We're going to talk about interpreting a dot plot first. So Jessica observed and recorded the number of birds on a tree at a park in the dot plot to the right. So it shows me all my pieces of data here. And the first thing I'm asking you is the sample size. I want to know how many pieces of data are in this. So I'm going to count the dots. So I have 1, 2, 3, 4. I'm going to label them 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3. 2, 1, 1, and 1. Okay, so the fastest thing for me to do is just to add those up. Since I am going to be calculating all this stuff here, I probably am going to use my calculator, but I'm going to start by not using it in the beginning. So I'm going to just add these up. So 5 plus 6 is 11, plus 5 is 16, plus 3 is 19, plus 2 is 21, 22, 23. I have 24 pieces of data. Okay, mean, median, definitely got to use my calculator. Mode, I don't need my calculator. Which number appears most often? It's looking like the 4 because it has 6 dots. How would you describe the data distribution? So is it, going back to the prior page, is it normal, skewed right, or skewed left? So I'm going to go with the tails on the right. So I'm going to say skewed right. Range is highest minus lowest, 12 minus 3. I'm using the numbers on the number line, by the way, not the number how many dots there are. So 12 minus 3 is 9. Interquartile range, I need to know my Q3 or my LQ and my UQ. So I'm going to use my calculator for that. So This is going to take a little while because I have to input 24 pieces of data. So I'm going to hit my stat button. I'm going to hit 1 for edit. I'm going to go up to L1. I'm going to clear out everything that's there. And then I'm going to input this data. So I'm going to hit 3 and I'm going to do it 5 times. Hard to not lose track. And I got the 3 from the number line down below, and there's 5 dots to the right of it. There are 6 4s, so I'm going to input in 6 4s. 1, 2, 3, 4, 5, 6. Okay, next I have 5 5s. So I'm going to do that. 1, 2, 3, 4, 5. Then I have 3 6s. 6, 6, 6. Then I have 2 7s. 7, 7. Then I have 1 8, 1 9, and 1 12. You should have 24 pieces of data. Make sure it says L1 with a 24 next to it, and 12 is the last one. And if you do not have 24 pieces of data, you did it wrong. Now you're going to hit the stat button. You're going to go to the right and hit calc, and you're going to hit 1 for variable statistics, and you're going to hit enter a whole bunch of times. And my N says 24, so I know that. My mean, my X bar, says 5.7083 repeating. That is my mean. Nobody sent around. So you're going to have to scroll down to get some information here. You're looking to find the median. So the median says med, it's 6. To find max and min is there. So max is 12, min is 3. So 12 minus, how I got this. 12 minus 3 is 9. So Q3 is 6 and Q1 is 5. I'm going to subtract those two, and my interquartile range is 1. Okay, so calculator is definitely helpful. I do not necessarily need my calculator to answer this question, but it definitely makes things a little faster. All right, let's keep going. All right, let's talk about a box plot now. So let's review box plots. So Madame Linné recorded the following French test scores, and she has a whole bunch here. Construct a box plot to display the above data. So last year, you put the data in order from least to greatest. So I'm going to try doing that quickly. 65, 65, although I definitely don't need to do that now that I know how to use my calculator, but I'm going to do it anyway. 70, 75, 80, there's 2 of them. 85, 90, 2 95s, and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I'm going to go to my stat button again. I'm going to go to 1. I'm going to go to my L1. I'm going to hit clear, and I'm going to enter in this data. I don't really care whether you put it in numerical order or you put it in the order in which they gave it to you. It makes no difference to me, but I'm going to substitute all of this stuff in. Please make sure that you are double checking that you're plugging stuff in correctly, because if you do not plug it in correctly, you are not going to get the right answers. You also need to make sure that you have 11 pieces of data that are going in your calculator. So I have all 11. I'm going to hit the stat button, calc, 1, enter, enter, enter. And I'm going to look for. So I'm going to scroll down a bit because I need the Fab 5 basically. So there's a lot of stuff in here, but I have to know what I need. So I need the min, the lower extreme, which is 65. My Q1 is my lower quartile is 70. My median is 80. My Q3 is 95, and my upper extreme is 100. So if you put this data in correctly, it's going to save you an exorbitant amount of time. In 7th grade, we used to make you calculate all of these things, and it was certainly much harder. Okay, so I am going to 65, 70, 75, 80, 85, 90, 95, 100. So I'm going to label the scale on my number line. So for this, you need to have, I call these the Fab Five. I need to put the Fab Five as a dot, just one dot, floating above the number line. So for my lower extreme, I'm going to put a dot here. For my lower quartile, here is 70. The median was 80. My upper quartile was 95. And my upper extreme or max is 100. So once I have 5 dots, I'm going to take the second dot and the fourth dot and make my box. I'm going to put a line down the third dot to make my median, and then I'm going to connect the first and the second dot to make a whisker, and the fourth and the fifth dot to make my other whisker. So I have my lower extreme connected to my lower quartile, my upper quartile connected to my upper extreme, and then I'm going to label it with a title. So French test scores. So now I'm going to answer the question. So now that I've constructed one, what is the range? The range is the highest minus the lowest. Well, the highest grade is 100, the lowest grade is 65, and we are going to get 35 as my range. What is the IQR? The IQR is the UQ minus LQ. So in this case, it is 95 minus 70, so my IQR is 25. Is the data skewed or symmetric? I'm going with symmetric. It doesn't really look like it's got some long whiskers. It doesn't really seem like there's some outliers in here. It's kind of got like this bell curve situation going on here. There are some low grades, there are some high grades, and there's a bunch of stuff right in the middle. Okay, most of that is review. All right, let's talk about interpreting a box plot. This time we're going to be reading one. John recorded the cost of lunch for the month of April in the box plot to the right. So now we're looking at the picture and we're trying to answer these questions. So cost of eating lunch for the month in dollars. So these numbers down below are dollars. Who is the median? That's the middle line in the center of the box, and that goes down to the number 6. So $6. $6. My first quartile is here where the box starts, and it's in between 5 and 6, so I believe I'm going to call that $5.50. The third quartile is over here in between 7 and 8, so I'm going to go with $7.50. The IQR is my UQ minus my LQ, or my third quartile minus my first quartile, so $7.50 minus $5.50, and that gives me $2. Range is my upper extreme minus my lower extreme. In this case, it is $9.50 minus 5, so that's $4.50 is my range. Is the data skewed or symmetric? So I would kind of feel like that this whisker is pretty long compared to this whisker. I'm definitely going to say that it is skewed. I'm probably going to say that it is skewed right. So the tail is sort of on the right-hand side. Each quartile represents what percent? 25%. In case you forgot that, each of the datas are quartiles, which is 25%, 25%, 25%, and another 25%. 75% of lunch costs were less than how much? So let's go. This is 70, 25. This is another 25. This is 25. This value right here is my 75th percentile. It's at $7.50. That's basically my upper quartile. What percent of a lunch costs more than $6? Well, here is 6. And what percent goes from here to here? Well, 25 plus 25 is 50%. 6 is my median, by the way, which would make sense. It's 50%. Okay, hopefully you're okay interpreting a box plot. Let's talk about histograms. So histograms, we're going to be interpreting those. So let's take a look at this. All right, I have to make this a little bit bigger. Okay. All the members of the high school softball team were asked how many hours they studied in a typical week. The results are shown in the histogram below. Okay, so what we need to do is we're going to take the information from our histogram and we are going to fill it in our frequency table. So you did this last year. We did frequency tables, we did histograms, we did constructing histograms, and then we're going to try and answer some questions. These questions are a little different than you did in 7th grade, but not much. Okay, so I'm going to label these. This is 4. This looks like 5. This looks like 11. 9. 5, 1, 1. Okay, so from 2.5 to 7.4, I got 4, 5, 11, 9, 5, 1. From 32.5 to 37.4, do you see how there's nothing there? There's like a space. There's a space there because it represents 0 pieces of data. And this is going to be a 1. How many students were there in total? Okay, I got to add them up. 4 plus 5 is 9, plus 11 is 20, 29, 34, 35, 36 total. Which interval contains the median? Well, median is the middle value. So middle is halfway. So what's half of 36? Half of 36 is 18. So I'm going to count into the 18th piece of data. So I'm going to start at the top, and I'm going to go 4 plus 5 is 9, plus 11 is 20. So somewhere over here I get to 18. Let's say I went the other way. 1 plus 1 is 2, plus 5 is 7, plus 9 is 16. Here I still get to 18 this way, and then I look left. And that is my interval that contains the median. So my 12.5 to 17.4 is the median. Modal interval occurs most. Which interval has the highest bar? Well, the one that has 11. Also 12.5 to 17.4. Which interval contains the 25th percentile? Well, 25th percentile, so median is 50%. Do we agree? That's how I got a half. 25 percentile is the lower quartile, is really a quarter of 36. What's a quarter of 36? It is 9. So what happens when I count into 9? Let's do here. So I'm going to start at the beginning though. 4 plus 5, I get my 9. Here I am. So 7.5 to 12.4 has the 25th percentile. That's where my lower quartile is going to exist, or my Q1. 75th percentile is 3/4. And that's of 36. 3/4 of 36, if you used your calculator, you would get 27. So again, I'm going to start at the top. 4 plus 5 is 9. 9 plus 11 is 20. 20 plus 9 gives me 29. That gets me to 27. And that goes over here into my 17.5 to 22.4. That's where my data would be. Okay. So I think we've answered all those questions. All right, let's head to silver and golds. I think I have, is there a sum it up or just silver golds? Just silver gold. All right, so I'm going to do silver. When I'm done with silver, there's a homework for you to do that you actually have to turn in. You can do it as a Kami, as a PDF, however way you want to do it. But that assignment is going to count. And when you're done with this video, you can turn it off and then move on to the homework. Okay, so let's see. Average minutes per night spent on homework for 120 sophomores. What percent of the sophomores spend more than 60 minutes on homework per night? So here's 60. And it's asking about more than 60. What's this percentile? So that each section quartile is 25%. So I'm going to go 25%. How many students is this? Well, 25% is 1/4. And I need to find 1/4 of 120. Use my calculator. And I get 30 students. What is the range of the times that the middle 50%, that's my box, of the sophomores spend on homework per night? So the highest part of the box, which is my UQ, is 60. The lowest part of the box is 20, which is my LQ. So Q3 minus Q1. That's 20, right? Yep. And I get 40 is my range. What percent of the sophomores spend less than 60 minutes on their homework per night? So less than 60 is this way, each worth 25%. So I'm going with 75% this time. How many students is that? Okay, 75% is 3/4. 3/4 times 120 is 90. So 90 students. What percent of the sophomores spend less than 20 minutes per night on their homework? So less than 20 minutes is 25%. How many students is that? We did that up here again. I'm not going to do it again, so I'm going to get 30 students. Would you expect the mean number of minutes per night to be higher or lower than the median? Higher or lower than the median. So mean is the average. So the median is 40. So let's take a look at this data. Do you notice that is it skewed or is it symmetric? So I think it is skewed. And it is definitely skewed right because it has a really long whisker heading to the right, which means there's an outlier here of, I don't even know what this number says, 190, I think it says, something like that. So it definitely has a number that's going to much higher than all the other numbers. If I have a much higher number, what does that do to my mean? It makes it higher. So mean is definitely greater than the median because it is skewed, right? Because outlier is very high. Certainly 75% of the data is 60 and lower. This guy's way out of proportion to the rest of it. Okay. All right. So Silver, I'm done here. That's a lot of review. I hope you got all of that. So we reviewed box and whisker plots, histograms, box plots, drawing them, interpreting them, dot plots. We reviewed how to look at distributions and what they're called. We reviewed all the key words here, and we learned a new way of how to input it into our calculator. That's a whole lot of stuff. All right, let's head to golds. So for golds, we have TV and homework minutes per night, and it's a box and whisker plot graph below that compares homework time and night and per night with TV time per night for the same group of sophomores. So the top, we're looking at two box plots. The top box plot is homework time. The bottom box plot is TV time. What percent of the sophomores watch TV for at least 15 minutes? So I need to look at the TV time, and I'm looking at least 15 minutes. So 15 starts here, and then we have anything higher than 15. So if I look here, at least 15 is 25, 25, 25 is 75% of them. What is the third quartile for the TV time data? The third quartile is my upper quartile, which is here, which is, I believe, does that say 110? 110 minutes. Is it more common for sophomores at this high school to spend more than 1 hour on homework or more than 1 hour watching TV? So let's discuss for a minute that the data that you're looking at up here is in minutes. 1 hour is equal to how many minutes? So it's 60 minutes. That's what I'm looking at. So let's talk about here. So how many people are watching or spending more than 60 minutes on their homework? I see 25%. Let's change that color. So 25% of these kids are spending more than an hour doing their homework. For watching TV, here's 60. More than 60 is now 25, is 50%. So it says, is it more common for a sophomore at this high school to spend more than 1 hour on homework or more on watching TV? I'm going to go watching TV. And I'm going to say 50% is greater than 25%. And that's how I'm looking at it. I'm looking at 60 minutes, which is 1 hour here. And I looked to where 60 was, and this I got 50%. Here I got 25%. And that's going to be my explanation. Okay, Gold, you're going to end the video here. Have a great day. Work on the assignment that's PDF and that you can either open in Kami or do as a PDF, and you're going to turn that in. Have a nice day.